I would like to hand the stage back over to my friend Scott. Are you ready?
All set?
All right. Thank you very much. Scott Guthrie.
Thank you. Great. So this morning we talked a lot about, or the first segment this morning, I talked a lot about Azure, and then I showed how you can use Azure App Service to basically host any type of web or mobile backend, whether it's written in .NET, whether it's written in Node, or Java, PHP, Python, you name it. We showed off some of the serverless computing options that we have with Azure Functions as well as Logic Apps. We showed off using containers and Docker and basically built a container and Docker-based application that we deploy to the cloud. And then I showed off and weaved throughout there some of the CI/CD workflow capabilities that you can leverage so you can automate all of that in a repeatable way. Whether the source is hosted in VSTS, whether it's hosted in GitHub, we can basically enable you to build it, test it, and reliably deploy it into a variety of different managed services inside Azure. So what I'm going to do in the second half of this talk is go even deeper. We're going to keep talking about a couple of different services that we have. In particular, I'm going to talk about some of our infrastructure services now and show off what you can do there. And then we'll talk about data. We'll talk about management, security, and a whole bunch of other cool things. So if we can go back to the slides now, let's switch gears now and talk a little bit about infrastructure. You know, I think one of the things that we try to highlight in the first talk was really about the fact that, you know, you notice we haven't created a VM yet. We haven't had to manage a VM. We haven't had to patch a VM yet. And that's partly the power of Azure is we can actually handle a lot of that infrastructure details for you and really enable you as a developer to focus on the app. But at the same time, there's going to be times when you do want to have a VM, where you have an existing app that you want to move, or you just want the full control that is provided when you actually own everything inside an image. And the great thing is Azure has a bunch of flexible infrastructure capabilities that enable you to take advantage of that in really rich ways. So one of the things that Azure has is the ability to create VMs. So you can create Windows VMs, Linux VMs, you can control everything, you can create virtual networks, you can put those VMs on there. We have load balancers, both standard layer 4 as well as now layer 7 load balancers that enable you to kind of do rich capabilities. And we have really rich hybrid networking that enables you to VPN into those images, or in some cases set up what we call an express route connection, which allows you to directly connect your on-premises network to the cloud over dedicated fiber network. And I'm not going to talk about any of that today, just because it's not that different than any other kind of infrastructure environment you might have seen. What I thought I'd do is instead focus on some new stuff, given a lot of people in the audience here have used Azure or at least seen Azure in some way, shape, or form, and talk about a cool capability that we released last year that is particularly well suited as you want to basically build large sets of infrastructure in the cloud and has a bunch of really cool capabilities that I thought we'd show off. And that's called VM scale sets. How many people here have ever used a VM scale set? Perfect, no one. That means it's all new and great. Either that or we've done a very bad job marketing it. So what is a VM scale set? Well, so with Azure, you know, typically what most of our customers have done historically is create an individual VM and treat that as an individual thing, and you can deploy anything you want into it and manage it just like you would sort of in an on-premises environment. You know, what's nice about the cloud, though, is we now enable you to kind of tear down and build things at a much more agile cadence, and you can now create much, much larger deployments of resources. And that's where VM scale sets comes into play. And basically, it allows you to dynamically create any number of VMs. You can dynamically scale them up or scale them down while still controlling what is in that image and having full control over that lifecycle. It also enables you to create images and basically roll out updates of them in a way without having to have downtime. So if you had, for example, a front-end set of web servers that you wanted to, again, custom manage instead of using app service and completely tune what's inside them, you could create an image of what your web server looks like. You could use a VM scale set to say, give me 1,000 of those, please. We'll scale them out for you. And then if you ever want to update them, you could basically say, here's a new image. Don't update all of them at once. Instead, gracefully walk through those VM scale sets, updating, let's say, 10 at a time, and make sure that you take those VMs out of rotation and put them back in rotation, and we'll handle all of that life cycle automatically for you. And you can manage VM scale sets through the portal, through a command line, as well as programmatically through an API. And so, a canonical example that we often see, especially for people building large base deployments, is to create a VM scale set, create an image, define how many instances you want. We'll go ahead and wire them up for you. And again, you can scale this thing out elastically. And when you create a VM in a VM scale set, you can give us a script to run as part of the first time the VM boots. You can go ahead and provide a Docker container image, and we'll go ahead and enable Docker and deploy that image in it. Or you can create a custom image and basically bake that image into an OS partition and have everything already pre-wired and configured, and we'll basically just create that VM directly from that. And what's nice about scale sets is you can use it in addition to standalone VMs that you're already managing. And so oftentimes what we see is people use VM scale sets for scaling out, in particular, middle-tier stateless operations, or anything that there's many of them. For things like databases, they might still manage them as individual VMs. The great thing is you can put them on a single virtual network and manage them all together as a single app deployment. And then once these things are deployed, you can actually manage them as a cluster of different VMs. So instead of just showing up as individual VMs in the portal, you can click on a scale set as a unit. This will actually allow you to see all of the resources together bundled up, and you can scale them up and scale them down. And I'll show some demos of that in a second. Built-in auto-scale support, just like you saw with app services, is built in. So you can go ahead and configure a scale set when you create it to say automatically scale out based on CPU. You can also do things like scheduling. So you could say, hey, on the weekend, scale it down or scale it up, using whatever custom rules that you want to be able to go ahead and apply. And one of the other nice features about VM scale sets is it has a built-in support for something we call over-provisioning, which sounds bad, but don't worry, it's a good thing. So basically what happens is if you want to create, for example, let's say 1,000 VMs, and on average, most cloud providers give you about a 99.9% guarantee when you do a create operation that it succeeds. If you have a 99.9 SLA on a create operation on a VM and you create 1,000 VMs, statistically, one of them is going to fail. And one of the challenges in a cloud environment is handling the error logic when that happens. The nice thing with VM scale sets is you tell us to create 1,000 VMs, we'll actually create 1,000 VMs for you. And we do it under the covers by actually over-provisioning and creating a few extra VMs. And then as soon as the first 1,000 come up, we shoot those and just give you the 1,000. And that basically means we can, if there's a particular node that's running slow for some reason, or if there's anything in the create operation stack that's taking a little time, you aren't affected. It gives you a very fast, repeatable pattern, and we only bill you for the 1,000 you ask for. So it's just sort of an internal implementation detail that we take care of for you. And as a result, this thing ends up being fast and highly reliable. You can actually create now 1,000 VMs, or you will soon. It's in preview, but in about 10 days, we'll support creating up to 1,000 VMs in a scale set. And they'll actually come up and be fully provisioned with whatever you want in them in under 10 minutes. And so that could be 64,000 compute cores of power, literally in 3 to 5 minutes on average, that will actually spin up and are available for you to use with anything you want within them. And then the last thing that's cool about VM scale sets is we deploy them so that they're not all running in the same place. And what this does is it gets you much more fault isolation, so that if, for example, we have a server go down, or we have a top-of-rack router that has a problem, or any type of failure at the storage layer, we can basically isolate it so that only a small subset of your actual deployment is impacted, and then we automatically create new VMs on a non-failed hardware device. And the benefit here, again, is if you're running a very large-scale deployment, you have built-in fault tolerance so that you can handle a whole bunch of different types of changes or issues that might happen in your environment. And this also is sort of different versus other cloud providers where you have to kind of explicitly place things automatically. The nice thing with VM scale sets is we do that for you automatically and take into consideration all those deployment characteristics. So let's see some demos here. So how would you create 1,000 VMs? Well, there's a couple different ways you can do it. The simplest way is to use the new Azure CLI that we're just coming out with. It's called AZ. It has a whole bunch of different commands, and so you can say AZ VMSS create is the command for creating a VM scale set. And in this case here, this is everything I need to do to create a new resource group called my resource group. I'm going to name this scale set my big cluster of VMs. I'm going to have it be an Ubuntu-based image. I want 1,000 of them. If I did have a load balancer I wanted to wire up, I just specify the name in that parameter, and I give it a subnet IP, well, it should be IP address, it's not up address. That was a typo. But other than that, that's everything you need to do, and that will basically cause Azure in under 10 minutes to create 1,000 VMs, spin it up, give it a name, and you now have a managed cluster of VMs that you can take advantage of. So let's go ahead and look at one that we created, just so you don't have to watch me for 10 minutes tap dance as it's booting up. And we're going to go back into, I think we're done with that, and that, and that. We'll go back into our management portal here. And here is a VM scale set that I deployed earlier. You can see here, I can actually manage it as an individual resource. So this is a scale set resource. It's showing me the CPU across all the VMs in this scale set. Right now, it's a very idle 0.34%. So it's not actually used for that much because I haven't deployed an app into it yet. But one of the things you can see here is I can see the entire cluster. I can choose if I want to scale it up or scale it down. And so if I wanted to shrink it down to, say, be only 58 VMs, I could slide that, hit save, and it will automatically shoot a large number of those VMs to bring it back to 58. If I wanted to scale it up, I could scale it up. In this case here, this is a 100-node cluster. We'll look at the 1,000 one in just a second. And again, it will automatically create new instances of that VM based on the deployment image I specified. I can also go ahead, and if I want to see individual VMs running as part of the scale set, I can go ahead and click the instance count here. And this basically allows me, if I want to see each individual VM image. And if I want to take action on several of them, I can say these three, let's deallocate, or let's re-image with a new image that I supply, or let's just reboot them. And I can basically manage these things again as more of a farm or a herd of different VMs all in a sort of single deployment metric. Yeah, again, just with that one command and then using these built-in tools, I can basically now manage any number of VMs I want in the cloud in a super flexible way. And then I'll show you, just to see kind of behind the scenes what's going on. This is a tool you can download. It's a little bit more of a dev art tool. But it basically is actually showing you the placement of these VMs. And so we do surface this as well through our APIs. And so this is a 1,000 VM deployment that I did earlier. And so you can actually sort of see here, although the resolution's a little hard to see. But each of these green nodes indicates an individual VM that's running. And you can see we've placed them throughout the data center so that we don't have more than 4 VMs on any particular server. So that in the event of, again, a server disk going bad or a hardware failure, I can basically isolate this so that my overall application is not impacted. And then Azure will automatically spin up any additional resources if a hardware unit does go bad. And they don't go bad that often, but hardware does fail occasionally. Again, that's all built in that you can leverage and take advantage of. And the support for 1,000 VM scale sets, today right now the support's at 300. The support for 1,000 will show up in the next 2 weeks. And again, this allows you to build super, super large applications, host any code you want within them. And again, it's another kind of pretty differentiated capability that you can leverage within Azure. So that's a little bit on VM scale sets. Now, one of the things I showed in this screenshot here was the new Azure CLI, which is also new and going to be available in general availability in February. It's available in preview right now. It's hosted on GitHub. It's an open source, and it's written in Python. And it's basically a new CLI that you can leverage in addition to PowerShell commandlets that we also have to basically manage all of your Azure resources. And what's nice about it is it works on Windows, it works on Mac, it works on Linux. and it nicely integrates with sort of the native shell capabilities on all three. And what I thought I'd do is actually show off some of the capabilities that are in the Azure CLI as well. So we can switch to the Mac now. How many people here have used the new Azure CLI? Okay, a few people have. So let's go ahead and show off what you can do with it. So this is the documentation page. Let's actually switch here and show off. And so one of the things you can do is you just type AZ once it's installed. And again, it works. I'm going to do it here in a bash shell, but it also works on Windows as well. We get the kind of the retro bulletin board view there. You can turn that off. But there's a bunch of built-in commands. And what's nice about this is you can effectively manage any resource you want in Azure through the command line. So I've been showing it through the web portal, which runs in a browser. I've shown it inside Visual Studio, where it's using the APIs directly. You can call the REST APIs directly. We also have a Java as well as C# API that you can program against to do everything. But the nice thing with the CLI and the PowerShell is it provides an easy way you can script a lot of things without having to write code. And the Azure CLI in particular makes it really easy to do things. So for example, if I wanted to see a list of all my resources in Azure, I just say Azure resource list, and it would fail. That was a spectacular demo I just did. What did I just do wrong? Oh, resources, yes. And if you read the error message, it will tell you when you have a spelling error, or just call it to people in the audience. Oh, gosh. There we go. Whew. And you can see here, this just went and pulled back all my resources that I'm running inside Azure. Now you'll notice right now it's pulling it back in JSON, which, how many people here love JSON? How many people here hate JSON? There we go. So the cool thing is, we love you all. So you can say Azure Resource List in JSON, or we could go ahead and say output table. And this will bring it back in a much more easy to read table format, which is harder to read when it's at a weird resolution like we are right now. Let's try that one more time. Slightly smaller, but open it up. There we go, it's a little bit easier to read. So you can see now, kind of in a much more easy to read format, all the different resources inside there. Let's say, for example, how many people here like to use grep or awk or other Unix commands? Cool. So the nice thing about this also is not only can you do it in JSON or in a tabular format. Tabular is easy to read. JSON's good for if you're using a JSON-based library or you're coming from a web environment. We also have a format called TSV, tab separated, which makes it look like that, which people in the audience are probably going like, why would anyone in the world want to have it like that? Well, the reason you might want to have it like that is it means that you can now pipe it to something like grep. And so if I want to search for things that have the word Phoenix in it, I could go ahead and grep and just pull back and filter those responses. And I don't have to worry about headers or other things being included as part of that. And so it naturally integrates with some of the shell commands that are, again, on a Mac or on Linux, where I might be grepping and filtering things in a variety of different rich ways. Makes it really easy to go ahead and compute it. We also have the ability to, and this, I'm going to cheat and just actually pull this here, to, instead of having to grep and do it on the client side, you can also specify what's called a query that is going to be applied inside Azure. And so if you've got thousands of resources, you don't want to have to pull that data down and do a local grep. In this case here, I'm doing a query where I'm basically saying if it contains a resource group Scott Goo Phoenix, go ahead and pull it back. And in which case here, I'm just, again, outputting it in a tabular format and listing it, which is a little bit more human readable and also more efficient on the network because I'm not having to pull lots and lots of resources back. The other thing I can do is with all these different things, if I wanted to, I could go ahead and let's say, instead of listing all resources, I could go back and just say, let's list my VMs. and do it at a resource-specific level. So this is pulling back a JSON version of my VM data. Again, I could, format it as a table. I could use the same type of query syntax to do server-side filtering. The other thing we've done is integrated with other existing tools out there. So for example, there's a cool tool called JPterm. This is used by a lot of, say, AWS developers. What's cool is our Azure CLI, because it just supports standard piping, you can now use it inside Azure resources as well. And so if I wanted to for example, do a filter and actually take back that JSON output and just project it so I'm only showing the name and the OS type, basically just plug it into the standard tool, and it will actually show me a way I can navigate and try all the filtering directly using the same syntax that I'd use with any other cloud provider. And again, makes it really easy to sort of integrate and take advantage of. And in addition to filtering everything, you can also create stuff. And so if you go to or get started in the docs, we have sort of a simple way that shows you how to create a VM. Somewhere inside here, create a Linux VM. And so in the same way that I could create web apps through the portal, I could go ahead and just type in AZVM create, again, specify the image, specify an SSH key, where I want to deploy it, and in one simple command, it'll go ahead, provision it, deploy it, and give me back the IP address to go connect to it. And everything I show that works inside the CLI will obviously immediately be reflected directly inside the portal. So if you haven't checked it out, it's definitely worth checking out. It's a great way, as you start to become more familiar with Azure and you want to be able to automate things to be faster, recommend either using the CLI, which works on all platforms, or PowerShell, if you want to be able to take advantage of the full PowerShell capabilities, and just start automating things. And just creating a couple simple scripts that you can check in can dramatically improve your productivity and allow you to get even more out of the cloud as you do so. So let's switch back to my Windows PC and talk about some of the other things that you can do inside Azure. And let's move on and talk about data some more. So one of the things that we have inside Azure is the ability not only to write code and create sort of infrastructure, but also to take advantage of rich data services that you can leverage as well. And specifically, we have two really great, we have more than two, but two in particular I'm going to talk about today, great platform services that you can leverage that provide both relational databases of service capabilities and NoSQL databases of service capabilities. They're called SQL Database and Document DB, respectively. With our SQL Database offering on Azure, it's a fully managed native cloud service. That means you're not having to create a VM, you're not having to install SQL Server or patch it or run it in high availability. Instead, all of that is built in and provided for you by the service. And we run it across multiple servers automatically for you. So again, if a hardware failure occurs, your app should never know it because we can automatically fail it over to another server and take care of that for you. It's designed to be able to be elastic, so you can scale it up and scale it down, just like you saw with the app service demo I showed earlier. You can also now scale it so we can automatically replicate your data around the world. So you could have a US version of your app, a Europe version of your app, and let's say an Asian version of your app, and automatically send users to the closest version that they're at, and replicate the database consistently across all those three different locations. And it has all the great features that SQL Server 2016 has on premises, things like in-memory column store support, row-level security, data masking, auditing, and a whole bunch more. And it is compatible with SQL Server, so you can take your existing code and very easily leverage it. The other kind of cool service that I highly recommend checking out that's really growing in an incredible fashion right now is our Document DB service. And what this does is it provides you with a NoSQL as a service option inside Azure. It's again fully managed, so again we take care of all the scaling and plumbing for you. It allows you to move from gigabytes of data to be literally hundreds of terabytes. I think our largest customer is running over a petabyte in a single instance of NoSQL. It supports rich querying support with automatic indexing, so it makes it really easy to use. and scale, and it's really high performant. One of the things that we do with DocDB that's pretty cool is we actually show you your performance latency directly in the dashboard, and our SLA basically guarantees sub 10 millisecond latency for reads at the 99th percentile and sub 15 millisecond latency for writes at the 99th percentile, which are great numbers, but the nice thing about 99th percentile means they're great numbers at an extremely high degree of accuracy. So you don't have lots and lots of stuff that's fast and then a bunch of stuff that's slow. And this gives you kind of the ability to build massively scalable apps and depend on that perf. Like SQLDB, you can set this up to run all over the world. And the nice thing with NoSQL database is that it makes replication even easier because you don't have to worry about foreign key constraints that you'd have, say, with a relational-based model. And again, this allows you to basically run this database in multiple regions around the world and build apps that can go against it locally with great availability and fantastic performance. The other cool thing that's built into our DocDB database now is MongoDB support. Anyone here use MongoDB? Great. If you've got MongoDB code, it works just against DocDB. You can use the exact same libraries, the exact same protocols, everything just works. The same code just works. We basically automatically can handle the MongoDB native protocol and translate that into DocDB and back. And so, again, if you're using MongoDB or you want to take advantage of the rich ecosystem around there, you can point it directly against DocDB and go. And you'll see us add more NoSQL heads on top of DocDB as well in the future that you can take advantage of and leverage. So let's move back to my Mac. And we're going to go ahead and show off another demo. So how many people have ever used the mean Scotch app demo that people have written for MongoDB, Node, and a few other things? No one. Okay, good. Scotch app, GitHub, we'll find out. I can't remember actually where it is, but the good news is, here we go. So anyway, it's a popular app, less popular now than it was a year ago, but it's basically a simple app that lets you go ahead and put pins on a map with your favorite programming language. And I happen to have it running here inside Azure. Oop, not there. Running here, and let's see if I can remember the URL. I think this is actually running in Europe. No, it's running in the US. I have different versions of it. I haven't run it apparently in the last year, so it's just spinning up. And what I should see after this thing launches in just a second is a map of the world where I can go ahead and put a pin on where it is. There we go. So for example, I could go here. Oh, I'm already there, but let's pretend this was done in Minnesota or New Mexico instead. And I could say my username is Scott Gu in near Phoenix. And I can go ahead and submit. And this basically just puts a little pin on the map and adds an entry into our MongoDB database for that particular user. So simple app, but it basically demonstrates, you can download the source from GitHub, basically demonstrates using Node, using MongoDB, and using AngularJS and Express and a few other things to build an app. So what does this code look like? So the cool thing is now I gotta remember where I put the code. It is, oh, here it is. Here's what the code looks like. Let me, in real time show you what it looks like. And so if you go inside here, this is totally unchanged code. The one thing I did do though is just in the config.js file is I added a new config entry for a document DB instance. and I basically pointed it at a document DB instance running inside Azure. And creating a MongoDB compatible NoSQL database is super easy. I can basically just go ahead and say, create NoSQL.db, give it a name, and I just select the MongoDB option when I create it, and this will now basically stand up a NoSQL database with the MongoDB API support wired up. And this is an example of what one looks like. And then basically all I needed to do was basically get the connection string out of this, copy paste it, stick it into that connection string inside the main app. I get deployed it to use Azure App Service, and this app with no other modifications just works. And this is the Document DB Explorer here that I can go ahead and use to actually see how many requests I'm getting against this instance. And as I mentioned earlier, we actually show as part of DocDB, pulling the telemetry metrics right now, this will actually show what the availability looks like as well as number of requests. And it actually will show you the SLA as well as what it achieved. And it actually shows the read latency as well as the write latency for any of the operations going against it. And so you can see here in the observed read latency at the bottom, on average, I'm actually averaging less than 2 millisecond read latency against this NoSQL database as part of this application, which is pretty good. It's actually remarkably good. And the beauty is I can see all of this for this particular collection directly built into the admin tool. And just like I could with app services to SQL databases, if I need to, I can scale it up or scale it down to take advantage of higher tiers and even more throughput. So an incredibly easy way, again, that you can go ahead and take advantage of this to build, both relational in the case of SQLDB and NoSQL in the case here of DocDB-based databases, and again, integrate it with all the popular ecosystem out there. So let's switch back now to the Windows PC. So I've shown off how you can store data in a relational or NoSQL way. Let's also now talk a little bit about what you can do with the data once it's stored. And one of the things that we firmly believe and we think the cloud really enables is the ability to take software plus data and put it together to create intelligent apps that can really delight your users and really get even more business value out. And inside Azure, we have lots and lots of rich analytics services. So you can spin up Hadoop clusters. You can do deep learning if you want to on top of our GPUs, taking advantage of, for example, the VM scale sets to scale them out over vast amounts of resources. We have data warehouses, machine learning systems, and a bunch more. What we also have is a really cool set of APIs we call Azure Cognitive Services, which enable developers who aren't machine learning experts and who aren't necessarily data analytic or Hadoop experts to actually still take advantage of the power of AI and be able to infuse it inside your applications. And the way Cognitive Services works is really easy. You go into the portal, you say, deploy a cognitive service. I want a vision API, I want a speech detection API, I want a motion detection API. We deploy it for you, give you back a URL that you can call as a developer with a REST endpoint and a key that we give you. And then you can effectively enrich your application by taking advantage of that. I showed that earlier with the Twitter app we were calling a sentiment analysis cognitive service API that I just passed in a string and it came back and said it was a positive or negative. I also showed it when I did that upload of an image and we did the text character recognition directly from the image. That was another cognitive service API. So let's go ahead and show off some other cool things that you can do with cognitive services to give you kind of a sense of some of the power that they provide. So I'm going to show off a cool app or set of templates that you can download. I think this is all in GitHub with a bunch of pre-built applications that people have worked through. One of which is called the Real-Time Crowd Insights app. Ooh, I look very red. Extremely red, actually. And one of the things you're seeing here is notice a couple things. One is the way that the box is following my face. So one of the APIs we have built in is called facial detection. And so it basically give it any image or video, and it's automatically detecting where is the face of the person. And then you'll notice it's also aged me, but it also will both guess the gender, it'll calculate the approximate age of the person, and then also what is their sentiment. And so notice I'm neutral right now because I'm just talking. If I smile, I'm happy now. And if I'm sad, I'm just a nice guy. So, but this is sort of an example of a client app that's calling these APIs. You know, you can get a lot of richness out of them. You know, what's cool is, and powerful is you can go even further if you wanted to. And so say, for example, you want to be able to not only know that this is a roughly 40-some-year-old man, but you want to know who that person is. But one of the things you can actually do is you can create and train models of pictures to actually do person detection as well. And so I'm going to go out to Bing. I'm going to pick a couple images of me. That's not me. There we go. And so this is downloading these pictures off the internet. It's always a scary thing to do. In a demo, we hit that play button, just train the model. And now when I go back to the real-time crowd insights, you'll notice it's not only now going to tell me how old I am, but it's actually computing who I am. And the age is closer too. But it's getting there. So anyways, that gives you kind of a sense of, you know, there's lots and lots of different of these demos you can take advantage of. The emotion detection, the face APIs, real-time insights. You can do kind of a bunch of really cool things. And the beauty is, again, all this stuff is just a couple lines of code. And we've got SDKs for C#, we've got SDKs for Java, for Node, whatever language you want. It's under the covers, it's just a REST API. And so you can literally, if you can make an HTTP call, you can take advantage of these. And you know, you manage them the same way that you would any other resource through the Azure Management Console, and we'll expose it through the CLI as well as the APIs as well, so you can automate everything as well. So let's go back to our Windows PC here. In our remaining time, talk about some of the other capabilities that are more cross-cutting services that you can leverage inside Azure. So we've talked about just sort of a small subset of some of the workloads. So, you know, web and mobile, about data, cognitive services. There's a lot more. I didn't talk about media. I could talk about IoT, identity management, much more on data services and more. Not time on that. What I want to do is instead switch gears a little bit and spend some time talking about some of the cross-cutting things that we're putting into Azure so that as you use all these different services, infrastructure and higher level, that you can actually run them, monitor them, scale them with the confidence and security that you need to actually really run a business and really be successful. And so what I want to do is show off a couple of the cool services that are now built into Azure that help you do that. Let's start by monitoring. So why is monitoring so important? Well, very important because when you deploy something, whether it's on premises or in the cloud, you know, knowing is it helpful, is it working well is pretty key. You want to be able to detect that before your users tell you you have a problem. And then when there is a problem, being able to figure out what the heck is the problem is really critical. And as you build microservice-based applications that might be deployed in multiple containers, as you start to use more and more managed services like database as a service or IoT as a service or app service services, you know, you got to know what might be having a problem or your app might be having problems dealing with when things go wrong. And so what we've done is launched this past fall something we call Azure Monitor, which is now built in directly into our portal. And again, it's exposed through APIs and command lines. And it basically provides a way that you can monitor all of your Azure services in an integrated way. It provides out-of-the-box metrics as well as logs. It allows you to set up alert rules, so you can say when something happened, like I see lots of errors, automatically page me or send me an SMS or send me an email. And it also easily integrates with other third-party tools out there. So if you're using Splunk or Datadog or various other analytic solutions, there's APIs so you can plug them in directly and be able to compose them as part of that workflow as well. And the way this works, and we'll show a demo in just a second, is on the management portal on the left-hand side, by default, you'll see something called Monitor, which is now exposed inside Azure. Click that, and then this right-hand blade appears. And inside here, there's lots of things that are available today. One's an activity log This basically allows you to see everything that's changed in your environment over some period of time. So it's like an audit log of who on your team changed what. This is really useful when you're in a team environment, something breaks. First thing to do is check what did someone change. Sam says, I never changed anything. And you look at the audit log and realize, oh, Sam just deleted a VM. And it correlates exactly when our app started having problems. That's a good, useful thing. We have metrics, so you can see the metrics for all your resources. We have log search. So I mentioned you can use something like Datadog or Splunk or other log, or Kibana or Elasticache or other search tools to search logs. We also now have one built in that you can actually use, built by Microsoft, that's integrated to the tool directly. And then we also have, as I mentioned, alerts so that you can set up triggers and notifications so that we can automatically notify you in a variety of different ways. So rather than just describe it, let's actually show it. And I'm going to go into my Azure management tool. And you'll notice right here is the Monitor tab. And so I'm going to click that. And this is launching the Azure Monitor experience directly inside here. And what you can see here, and actually let me just do one other thing, which is I just realized I have two subscriptions in Azure I'm using. One's my Hotmail one and one is my Microsoft one. Let me quickly show you. This one, since that's the one we've been doing our operations in. And so, for example, we'll start off here and then we'll flip to the other one. You'll notice right here, when I launched this, I went to the activity log by default, which is this first entry here. And this basically gives me a way to see everything that's changed from an API or from the portal or from the command line within my Azure subscription over the last period of time. And so you can see here, I can filter if I have multiple subscriptions, which one it was. I can save a query, so if I want to have, what did Sam do? I can just persist that if Sam is the one that creates problems. I can also search and say, do I want to look at all operations? Do I just want to look at creates or deletes? I can look at different types of resource types. So I could say, just show me app service work. And you can also search by who initiated it, et cetera. So it's pretty rich search capability. And you can see here everything that we basically did throughout our deployments. You'll notice we updated our website a few times. We registered a new resource. We restarted something. I don't remember that, but apparently I did. You can see I updated my config. I got my credentials at one point. This was when I actually used my CLI over here and logged in. So this will even tell you, hey, someone actually tried to log in and get a certificate to be able to use. Here's where I swapped that production slot earlier and so forth. And for any of these, you can basically go ahead and bring up the details, and it'll tell you who did it, when did they do it, and it'll show you the underlying operation that actually took place. And so even including the claims as well as the underlying API request that occurred. So very easy way that you can go ahead now and see everything that someone has changed throughout your environment, what did they do, and then better understand why did they do it. So I'm going to switch over here now to this other account, which has some other resources and has log search wired up. So the other thing I can do inside Monitor is look at individual resources. So for example, if I wanted to, I could go ahead and pull up individual resources, say virtual machines. And if I wanted to, I could go ahead and look at all the metrics for that particular VM. So if I want to see how is the network doing on that particular VM and what's the network out, I could basically go ahead and automatically pull up the diagnostics for that. I could do it one-off, I could save it. The other cool thing I can do is I can pin it to a dashboard. And so if I pin it to my dashboard, one of the things you'll notice is now when I go back to my dashboard view, there is that version that we just saved. And cool thing you can do with Azure, if you haven't figured out, is you can go edit dashboard, and you can also go ahead and resize things however you want. And you can also move stuff around to be wherever it makes sense best for your particular organization or team. So you can kind of have all heads-up display of all your common metrics saved there. The other cool thing you can do with the Azure Management Console that a lot of people don't know about is create a new dashboard. So if you want to create this and call it Scott Goo in Phoenix, you can do that too. And so I go back to my Monitor experience, and click on that diagnostics. And of course, I should have just restarted the one I was already working on, but whatever, we'll pick a different VM here. If I wanted to look at, what's the disk I/O here, pin it to my dashboard. This will now pin it to this Scott Goo and Phoenix dashboard, and I can then very quickly flip to any of the other dashboards I already have configured and load them up as well. So this is a great way that if you're in a team environment, your development dashboard might be the resources you're working on, and then you might want to have a quick monitoring in production dashboard that you can flip to that has the heads-up display of all the actual production resources. And again, you can save these tiles with the appropriate real-time statistics based on the role or the use cases, and you can also share the dashboards across your team. It's a great way you can create sort of a nice heads-up display. And you can also go to full screen mode if you do buy, say, a flat panel monitor and want to put it up in your hallway. And that way you can get rid of all the other ones and just have the monitoring data for your application. So all that's kind of built in, and if you haven't taken advantage of it, it's kind of a cool way that you can leverage the built-in support in Azure to do a bunch of stuff there. Now, metrics is useful, and being able to see a heads-up display is very useful so that you can kind of tell, hey, our VM is running slow, our app is actually throwing some errors. It's useful to be able to see that there's a problem, but when you actually want to understand what the problem is, you typically are going to want to first check the logs for that particular resource or be able to run custom queries against your infrastructure to be able to kind of diagnose what's going on. And that's where the built-in log search capabilities of the Azure Monitor system really come into play in a nice way. And what that basically allows you to do is wire up the ability to effectively get an in-portal experience where you can run arbitrary queries against all the data that your apps and resources have gone ahead and saved. So for example, I could write a star query to begin with here, and this is going ahead and searching the logs for this particular environment I have stood up, and you'll see there's 6 million unique entries in my log files that I just brought back as part of that query. And so you can search over lots of data. It can literally be petabytes of data that if you want to search. If you want to see all the different types of entries that I currently have configured to bring back, I could change this query. And here I'm basically bringing back a query where I'm just sort of searching for the type. Oh, and I did that wrong. I did autocomplete, so I'll just search it by type, and you'll actually see, instead of just type protection, I can actually see all the different types of types that are coming back. So I have 41 different types of log entries in my log files, and you can see kind of that full list of them. One thing you might notice, I believe is still wired up with this subscription somewhere in here, is I'm actually bringing back VMware metrics as well, because I can actually take the log files that I have not only in the cloud, but also from on-premises. And so if you're running on, say, VMware or Hyper-V, you've got SQL or Exchange, you can pump all those logs automatically into this environment and now have a single way to index and search all of it, regardless of where it's actually running. Even if you have VMs inside Amazon, you can pull that data and actually use this environment as well. And then if I want to run something richer, so say, for example, of those 6 million entries, let's run a query that's going to pull back everything coming from my SQL databases. This is showing me my resources across my Elastic database pools, which is a cool feature inside SQL. And I can actually see what is the CPU performance across all of them. Hey, there's a dip right there. Let's go ahead and zoom in on it. And I can actually now drill in and see just the subset of that data and understand what's going on a particular resource level. And everything I can see in chart form, I can also pull back in tabular form to actually be able to see the individual entries. And so whether or not it's coming from a resource I have in Azure, whether inside my application, let's say I'm using .NET and I'm just using system diagnostics to write my own string into the event log, all this is indexed, all this can be searched, and all this is sort of built into the overall experience and lets me take advantage of some pretty powerful stuff. And just like you saw earlier, I can actually create dashboard tiles for all this information, and again, put that on my heads-up display so I can have kind of full customization configuration as part of it. Other things I can quickly do, and right now it's an extra, wiring this up, you got to click add twice, and so it's going to be even more integrated in terms of setting it up soon. but you can see it's kind of integrated even as part of this experience. We also then have alerts, and so I actually have a lot of alerts set up as part of this. Blah, 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 we won't look at that one. Should fire, that's always a good one. And so if you want to set up a new alert, let's not look at that one, I have no idea what that is. If I want to, let's say on a particular resource, wire up an alert. Oh, I don't have any on there. Okay, never mind, let's actually take it back. Let's just look at the alerts we already have wired up. I think this blah, blah, blah one, it should be interesting. This is a shared subscription with a few other people that do demos. This is awful, wonderful. Thank you. The danger of whatever. So you can basically pick whatever metric you want. So in this case here on a VM, I could look at, for example, say .NET CLR time in JIT and pull that back. I could then set a threshold. So I say if it's greater than a certain period of time over the last 5 minutes, basically alert that something's going wrong in the system. I could email the users, or I could basically email anyone I want, or I could set up a webhook. And so I could call, for example, an Azure function, or I could write arbitrary code. We also have built-in support for what we call runbooks. And so as part of a runbook, you can upload your own custom PowerShell, or we also have a built-in set of runbooks here that it's populating. And so, for example, we have default ones like restart the VM. So if we see that, hey, something's going wrong with the VM, just restart it. It'll pull it automatically from the load balancer. So if you're running in, say, a load balance configuration, your customers won't know, and you're automatically rebooting it. Or you could just upload your own custom PowerShell or other CLI script, and you can basically execute it as well. So really easy to wire all this stuff up, and again, get automated capabilities built in. And then the cool thing we also now have is what's called notification groups. And what this lets you do is, instead of just sending individual user a notification, you can create a notification group and basically say, here's who's on call. And basically have a pre-built group called on-call developer. And whoever is on call will then get the notification, and that way you're not having to change lots and lots of different alerts to hard code in individual users. And as part of this, you can also do SMS notification. You can integrate with things like PagerDuty and other popular tools out there. And again, get a kind of complete monitoring experience, kind of all built in, that you can take advantage of as part of this. So that's a little bit about monitoring. And you're gonna see it get richer and richer over the next couple months as we build in more and more monitoring capabilities inside the service. Not every service today, I'll be upfront, has the monitoring metrics currently in the metrics dashboard. We still have some services that don't, but basically you'll see every week more and more of those metrics show up. And our plan is sort of by the next couple months, 100% of all Azure services will have it in there. And so all the stuff I'm showing, alerts, notification groups, log search, as well as the metrics, you'll be able to take advantage of in a consistent way throughout a single system. Last thing I'll show quickly also in terms of capabilities that I know is top of mind for a lot of people that are thinking about cloud is security. And as you build apps and as you run them in the cloud, I think one of the things that people often both wonder and worry about is, hey, is this stuff secure? Do I need to worry about someone breaking in? How do I basically make sure that my environment is safe? And security is kind of a multifaceted problem. At one level, it's important for us at Microsoft to make sure our infrastructure is secure. And so we're working super hard to make sure that we lock down things as much as we can and really do the absolute best security practices we can. You saw in the video as an example, when you go into our data centers, you have to do biometrics controls for even our personnel to actually get into the facilities. Everyone has to go through metal detectors so we can make sure no one's bringing in or bringing out any hardware from that system. And as an example, when a disk goes bad, we don't send it off to the manufacturer to go fix. Instead, we actually obliterate it, which is one of the cooler things. If you ever do one of our data center demos, we let you obliterate a disk. And when I say obliterate it, I mean we really obliterate it. Because SSD drives now have even a millimeter of SSD retains data. And so we literally drop it into a machine that turns it into sand. It is the coolest part of what my team does. When I'm having a hard day, I just drive out to a data center and I just obliterate things. We also then obviously have lots of logical controls that we do across our software. The thing though that is really important to think about with security though is it's not just us that needs to worry about security, you need to worry about security as well. And if the infrastructure is secure but there's problems with the app or problems with how the app takes advantage of the infrastructure, you can inadvertently create security issues. And so one of the things that we built into Azure now, I think it's really quite differentiated, is something we call the Azure Security Center. And what this does is it allows you to look at all the apps and resources you're deploying on Azure, and it will actually tell you whether or not we see anything that's happening that is insecure, meaning you've configured something wrong, or you're not taking advantage of the best security best practices, and will actually notify you. We also then do a whole bunch of monitoring, so we can actually tell you if we think someone is attacking your environment, and we'll actually proactively alert you. And what's great is if you already have approved security software, say something from Barracuda or Cisco or Checkpoint or Trend Micro or F5, we integrate all their signals as well and give you kind of a unified heads-up display that shows off all of what our security systems are telling us and then what the third-party ones might be as well if you're running them inside your applications. And the way to get access to all this is, just like you saw with monitoring, you can just go to the Security Center on the left-hand nav of your dashboard. And this basically brings up this tile here. This is now looking across all my Azure subscriptions and will basically tell me proactively anytime we see something that's being done inside these subscriptions that is not a best practice. And so let me first tell you, this is not my personal subscription. It's actually a really good demo security subscription that has lots of things wrong, in case you're wondering why I have 319 high security issues. I like to think my personal stuff doesn't, but this one is an environment that kind of shows off, actually, though, a fairly realistic set of scenarios that we often see, say on-premise systems often have, but which are often difficult to detect and people might not realize. So for example, here, this is showing me all my VM issues inside the subscription. And you can see, for example, I don't have endpoint protection turned on 67 of those 175 VMs that I'm currently running. I'm missing security updates on 18 of the VMs. I've got 17 of the VMs that I patched, but I forgot to reboot the VM. And so as a result, even though I've patched the instance, because it's not rebooted, it's not fully secure. A really common problem when people are doing patching. I don't have disk encryption turned on, which is a feature we support in Azure, on 48 of the 175 VMs and so forth. And so the nice thing is I can go to this dashboard and I can see this and I can take action immediately in order to fix them. Not only can I look at VMs, I can look at things like my network. And so, for example, we have rich networking support inside Azure, so I can set up subnets and I can set up security groups and security rules. This basically is telling me, hey, I've got deployments where I've got way too many ports open. I've got subnets that are way too promiscuous. This machine never talks to this machine, and yet you've opened it up so that they can. You should really lock that down at the network level to basically partition your application to be even more secure and so forth. Same for data, same for applications. So all this stuff's built in and it's free. And we're constantly scanning your environment and we basically surface it directly for you. And you can control who gets to see this. We generally recommend let your developers and your IT staff see this. And again, set up an automated alert. Anytime we see something, you can jump in and take immediate action. The other thing that we then do is scan your environment for when we see active attacks. And so we have a bunch of machine learning that we've built in, so we can actually tell you when we see that people are actually probing something against your environment, and can actually warn you if we see what looks like suspicious things that might indicate an actual exploit that's underway. And again, we do this against both the data that we can see in our environment, but also if you've got third-party security software, we're importing that data, and we basically allow you to see that as well. And so, for example, we're seeing in this application right now what looks like a SQL injection attack that's happening. So there's a web page, someone's trying to enter in, instead of enter your name, my name's Scott, semicolon, drop database. This would detect it. And that's built into our database as a service offering, that type of detection and support. More commonly, people are trying to do a select star and actually do exfiltration of data. We probably warn, on average, over a dozen customers a day that they've deployed an app where they've have a SQL injection bug inside their code, and it looks like someone is trying to actively exfiltrate data. And when you see that, you can now take immediate action. And obviously that's scary, but the nice thing is the system's now warning you, and you can turn on the ability to detect it. And then we can also look at all these signals and noise and try to actually see a timeline view when an actual attack has happened and actually warn you, this isn't just some noise we're seeing, this looks like an active thing that's happened. So in this case here, an actor tried to attack with SQL injection. It was blocked, which is good. It then tried to do what's called a brute force password attack, where it bought a bunch of passwords on the internet and just tried randomly logging in. You'll notice one of the passwords succeeded. We then basically saw in this VM, because it turned on endpoint protection, a service just ran that has never run before. And you can now see it starting to query your Active Directory and actually move laterally across the network. And then we just saw and detected what looks like malicious network communication to an endpoint outside of your environment. The beauty is this is all built in. And again, can give you kind of even more radar about what's going on in your environment. And hopefully you don't see things like this if you follow the best practices, which is what we show at the top of the tool. But having that ability to both kind of see best practices as well as detect when things are going wrong, again, enables you to run all types of systems with much more confidence securely in the cloud. And what's nice is everything that is exposed here through the GUI is also exposed through an API. We have built-in connectors to things like Splunk and ArcSight. So if you are in an enterprise that has a network security operations team, they can take the existing tools they use maybe for on-prem, take those signals and basically see them in the same dashboard views that they use today. Last thing I'll just mention that's now live for every Azure customer is the Azure Advisor. How many people here have used Azure Advisor? Cool, only one. It's not really cool, but it's cool for the next 5 minutes. Definitely worth checking out. It's free. Basically, it'll show up in your left nav soon by default. Until then, just go ahead and say more services, and type Advisor. And you'll see this little owl creature, and just click that little thing, and it will add it to your left nav. And when you click it, this basically launches a tool that you can point against any environment. So for example, I'm going to run it against this. This is a friend of mine's demo environment, so we'll see what he's done wrong. And what this is doing is basically looking at the environment, proactively trying to identify what are best practices, not just in the security space, but across Azure that we think you might want to take advantage of and do that'll enable your experience in the cloud to be even better. And so, for example, some of these ones here is, please follow security best practices. So it saw all those issues that we saw in the Azure Security Center, and said this is a high vulnerability. One of the cool things here is it's not just about security. Check out this one. This one's basically saying you're paying us too much money. Take your money back and spend it on something else. Our sales team really hates this feature, but this is, we think, nice and gives you, again, a way that, as you're more successful with the cloud, we know you'll ultimately start to do more and more with it. And so this basically is literally telling you, if you actually read this particular metric, here are 4 virtual machines where your usage pattern over the last 30 days indicates that you've over-provisioned them. You're running a large VM, you can get away with a medium or small, and your users would never know. And so you can actually see, here's the potential savings in dollar values every single month that you could realize just by resizing that VM. Thank you very much, and again, make you more successful. We also built in support for fault tolerance. One of the things we often hear from people is, hey, I deployed something, I thought I had high availability turned on. I had 2 VMs up, and I have a database within them so I can fail over, or I can basically run high availability. But a lot of times people forget to turn on and tell Azure this VM and this VM are part of the same availability set. Please don't put them and don't update them if you patch at the same time. This, again, will flag anytime we see, hey, you've got VMs that are not in the high availability set, and you should go ahead and configure it, and so forth. And so we're adding more and more of these rules. Again, it's free to run this. Again, it's a good way that you can save money, you can get more secure, you can get more reliability, and again, it's just built into the portal. You're going to see more and more things show up in this left nav that kind of help with that cross-cutting experience over the next couple months. There's a cool video out there. I forgot to get the preview flagged, or else I'd demo it today. All the CLI stuff that I showed when I was going to my Mac in the bash shell, we're actually supporting a cloud shell directly in the portal, and so you can actually write your bash scripts directly inside the browser, regardless of what OS you're on. That'll be showing up hopefully in the next couple weeks. You'll see much richer network traffic log analysis, so the individual packet flows that are going on across your virtual networks. That also is in private preview and will show up publicly next month, and a whole bunch more. And the end goal here is not just we have cool services that you can use from a development perspective, but all these things give you that confidence to scale it out and be able to run it in a mission-critical way to serve your business.
Wow.
So I've talked about lots
amazing.
of stuff. I think I'm done for the morning here, and we got to do
How many of you that
session,
security
but-
stuff was new where you hadn't seen that before? I have never seen that security flag. That's the most awesome thing I saw all morning.
Cool.
That is brand new. I'm a little afraid to look at it.
Please do look at it.
I'll look at it, but not publicly.